Hello everyone. Today we are going to discuss about challenges in implementing smart grid. Last three videos we have been discussing about smart grids. Smart grids are basically an advanced electrical grid with a communication capacity which come through digital technology and automation technology. We can create the communication capacity, or we can embed the communication capacity with the power flow. So now today we are going to discuss what are the challenges. Last videos we have been discussing what is mean by smart grid and what are the advantages, what are the applications. Now we are going to discuss about what are the challenges in implementing smart grids. So first challenge is a high initial cost. Upgrading to smart grid involves significant upfront cost, including infrastructure, advanced meters, sensors, and control system. We know that smart grid should have a smart devices. Smart devices mean the devices is connected with the internet, IoT things, and it can able to communicate. It can accept the command and it can send the signals, data to the control center. So we need a smart sensors, smart energy meters, smart voltage measurements, smart current measurements. All the devices, all the measurement devices should be smart meters, and we need a control system as well. Control system. We need to control everything together with the computer programming, all sort of things. So we are actually running the automation system in power sector. So we understand what is mean the automation system that we are applying into the power sector. So we need the cost to set up this automation system. It's high. The cost can be barrier for regions with limited funding, for consumers who might face increased rates to cover the investment. In order to cover the investment, actually at the end we are increasing electricity price in order to cover the expenses caused by this smart grid implementation. So that's a problem in high initial cost. Second one is a cyber security risk, because here this the connectivity and automation in smart grids increase vulnerability to cyber attack, which could disrupt the power supplies and compromise consumer data. So why? Because here everything is connected with the internet, like, so all the meters, devices are connected with the internet. So instead of we control the breakers or switches, if someone else control the switches, I mean, we power system engineers sitting at the control center, the electrical distribution center or the control center, we can control the relays, breakers, power generation, grid connection, off grid mode, everything we can control. Instead of we control, if someone else through the cyber attack, if they control, there's a problem. So utility must invest in robust cybersecurity measures, often adding to the complexity and cost of smart grid deployment. So again, is a cost expensive because we need to protect the our system from the cybersecurity risks. So next one is a privacy concerns, because we are in delivering providing data in real time. So real-time data collection and monitoring can raise privacy issues for consumers, as smart meters and devices can reveal detailed information about the household energy use. Here's a key: many countries we cannot collect the data about the individual household energy consumption. Like in Australia, while I was doing the research, I found very difficult to get the data about customer demand usage pattern. I mean, every hours, how much amount of energy they are using. Because it's because of the privacy concern, they are not revealing those data to even for research. And if we really want to buy, it's expensive to buy these data. I mean, data can be sell. I mean, they are selling this data. If you really want to do research on the individual customers electricity usage pattern, then we have to buy it. in a much expensive price. So what is the concern here? I mean, by knowing their energy usage pattern, we can know that what time they are sleeping, what their time they are waking up. So it means their privacy information can be revealed by energy usage pattern, because obviously we know that if the electricity usage starts when they wake up, they put a coffee maker and oven or sort of thing. So I mean, obviously we know that we use electricity more when we are active. When we go to sleeping time, we reduce the usage. I mean, almost all only air conditions, also small lights are on. So based on these smart devices, we can easily find out the privacy information. Okay, that's a problem. So we need regulations and safeguard the necessary to protect the consumer data and ensure its responsibility. So we need again protection through the regulations. So who can use this data? So data is a big thing here, big important matter here. So next one is interoperability and operability and standardization. The integration of various devices, sensors, and softwares from different manufacturers can pose compatibility challenges, because when we talk about smart grid, all the devices should communicate. So in this case, like all the devices, if we installing devices from different manufacturer, different product, then bringing one communication is difficult. Let's say if we take Apple product, always have a capability of connecting with Apple product. Usually the Apple mobile phone, Apple laptops, Apple, so they have a different zone of connecting together. So if we are using a different mobile mobile from different manufacturer, then we found difficult to communicate with Apple products. Similar to that, in power system, if we want smart grids, and we it's a challenge to bring the communication between different set of devices manufactured by different companies, because the IP address, all sort of different things, parameters set up, all sort of things may be critical things for communication. That's more related to the IT and how the product is designed to communicate, those kind of things. So standardization across utilities and regulatory bodies is essential to ensure that all components work together seamlessly. Okay, that's the thing. We come to the last slide. What is the last problem is the technical and workforce challenges, because managing and maintaining smart grid require the advanced skill. As we know, like we have been talking about new terms like dynamic pricing, demand response, a lot of new terms. The people who are working with the smart grid technology need to know these terminology. They have to understand what is going on, how the power system working, what is a for energy forecasting, demand forecasting, a lot of things. What is renewable, non-renewable, and data analyst. We need data analyst with the energy background. I mean the power background. They need to know about the power sector, or how it's working, what is active power, reactive power, and also they need to know the data analytics skill, and also cyber security expert. We need cyber security expert to protect our system from the any cyber attack. So finally, utilities must invest on workforce development, because they need to develop the workforce. It's not just like a conventional power system where the hydropower plant, thermal power plant, the people are working in those power plant with a mostly about the mechanical background, and people in the conventional grid supply, they have the fully only electrical background. But in this case, we need a mixed background people, the knowledge people to work. So that's all for today. We come to the end of the slide. Thank you very much. See you in the next video.